Welcome to Future Forecasting of Time series using a long short-term memory. I am Karim Tariq, your session lead. Long short-term memory, or LSTM, is one of the key foundations of large language models, which took the media by storm. In this session, we see how using it can help us achieve our business goals by forecasting time series to help us predict the future of our sales, stock prices, and product demand. Okay, so we will start by explaining what is an LSTM, how does it work, why it's there, and give an example of using it for future forecasting of time series. First thing first, what's long short-term memory? Imagine your brain trying to remember a series of events like the steps to bake a cake. Some events are crucial, like adding eggs, while the others are less important, like what you are wearing. We need a smart way to decide what to remember, what to forget, and when to use the information. How does it work? Long short-term memory has a notebook with the recipe steps that keep track of things for a long time. These are called memory cells that help the network learn which data to remember or forget. It also has gates that act as decision makers, which control the flow of information. For example, it has an input gate that asks the question of, shall I write this new information in my notebook? The forget gate asks, shall I erase something I don't need anymore? And the output gate asks, shall I use this piece of information right now? This helps a computer remember important information for a long time and retain important information over many time steps. It also handles information that happens in order, like time series forecasting and word sequence. Why it's there? It all starts with how the brain functions. We receive our brain to be functioning as if it has like a logic unit and a memory unit because of the way we perceive our brain to be making decisions by reasoning and experience. The computer mimics this by implementing a processor responsible for arithmetic and logic operations and a hard disk or RAM to store the relevant data. On the other side, neural networks seem like a black box. You give it some input and you get some output. Decision is mostly based on the current input and the learned parameters during the training iterations. We need to remember relevant information or relevant input for later use. For example, we may need the stock data from a time frame to use it for investment judgment in the future. So the naive way to accept a time series data is to connect many neural networks together. Each handles one time step. This resembles an unrolled recurrent neural network, as you can see from this screen. Recurrent neural networks are multiple copies of the same neural network, each passing a message to its successor. It can connect previous information to the present task. For example, using a previous video frame to understand the current or present frame. This is good when the gap between the relevant information and the present use case is small, but the gap can get larger, which leads to a problem known as the vanishing gradients and exploding gradients, which makes the neural network unable to connect the information. A very well-known example is a very long word sequence, where we need to predict later statements based on a context further back in the story. So, in summary, long short-term memory is a major pillar of large language models, a type of recurrent neural network architecture that help a computer remember important information for a long time, uh, and it doesn't lack the problem that recurrent neural network suffers from, which is vanishing and exploding gradient. Thanks for listening.